Hey, we're back and we're going to do a long question here, number 4, drive into the game, or maybe further, a game in San Francisco. So, hybrid car, and the first question asks, is the relationship between the amount of gallons of gas that the car burns up on a full tank, is it proportional to the amount of miles that it can drive? And so if we look at this here, I've set up a 12 gallon for 420 mile fraction, which is the proportion, which reduces when you divide by 12 on top and bottom to 1 over 35. So 1 gallon is burned up at 35 miles. What is that sound that keeps going off? I mean, who is here? What is going on? It's like a radio or something. Oh, hey, look.
It's me, guys.
It's Elvia. After school, guys. What's she going to tell you? What's your message to these kids?
To behave good and listen to Mr. Dave.
That's right. Already got the relationship, 12 gallons for 420 miles. So every mile is 35, every gallon is 35 miles. So therefore, well, 3 would be 105, 3 times, you know. So 0 is 0, because why? Well, when we got no gas, we ain't gone nowhere. You know what I mean? We haven't driven anywhere. So now we've used 3 gallons, therefore we've gone 105 miles, right? 35 times 3. And then over here, we just double it, 210. That's it, 210 miles. We've gone from nowhere, everybody knows this is nowhere, to 105 miles. Then we double that, and the table is done. Let's look at what that looks like on a graph. We just graph it. We have our axes, distance, miles on the base, and the x coordinate. And then on the y axis, we've got gas used. So we simply plot those points. We start at 0, 0, and 3, 105. Boom, boom, boom. 3, 6, 210. And there's a 210, just slightly over there. Here we go. Create a line here. Did that radio go off or something? I hear something in the background. Hello? What?
Mr. Dave.
What? Ah! Now, not again. I think we have the one and only. We can check this. Because I don't know if I'm doing this right, honestly. Again, Miss Tovar is here to check this. Well, Miss Tovar, what do you think? What do you think of that line?
It looks very good.
Really?
It looks very right. You did a good job, Mr. Dave.
Okay, well, thank you very much. Honestly, I think it looks it's a little sloppy, but I'm going to make it a little bit straighter because
But practice makes perfect. So.
practice makes perfect. I think the kids should know that, right? Kids, practice makes perfect. Perfect. You know why? Because Miss Tovar says practice makes perfect. She's here every day after school helping kids learn, making sure that they practice. So maybe you should join. Practice makes perfect. Come after school. Infomercial for the after school program. All right, guys, now we're about to finish this off because the hardest thing I think for most people is to find an equation of the line. We got the table, we filled in the stuff, we graph it. Equation of the line has to do with the slope and the y-intercept. All right, well, slope is related to the unit rate. We found the unit rate. We essentially have found the slope. Let's look how that works on the graph, and let's see what that does on our equation of the line. So right here, we can put a triangle together here, for instance, and once we put a triangle together, we can realize that, oh yeah, between here, it goes up 3 and over 105. Well, that's exactly what we had. Rise over run, right, equals 3, 105. In other words, when we reduce that, we got our golden number, 1 over 35. That's our slope. It's also the unit rate. Same thing, same thing. Now, let's see how we can use that in the equation of the line. Equation of the line is based on our good old friend, yours and mine, y equals mx plus b, right? So here, y equals mx plus b. M is the slope. Remember this, everybody? You've done this before. Why M? Nobody knows. Nobody really knows. It's a mystery. $1,000 if you can tell me who invented M. Maybe 1,000 points. M equals slope, and B is the y-intercept. That means where the y-axis, where the line crosses the y-axis. Well, where is that on the graph? Nothing other than right here, right there, at ground 0, 0, 0, no gas used, no distance driven, hybrid in the garage, if you know what I mean. And then we can go ahead and say, okay, well, B equals 0. Well, because it's 0. There's nothing happening there. But M is equal to, let's put it together, M is equal to, right, 1 over 35. We figured that out. We just put it all together in here. We substitute m in there. We get 1 over 35x plus 0. In other words, we can rewrite it without the 0. 1 equals 35x. That's it. Our equation of the line. We've got our graph. We've got our table. This is boys and girls, young men and young women. This is multiple representations of data. This is something that's happening. People are driving places. People buy cars, they put gas in them. Things happen. This is representing an entire story, a math representation of an entire journey, a place to go, people to see. The most important thing is that whoever went through this experience, Robert in this case, had an internal experience, much like the kind we have when we take a deep breath. So let's take one last thing, deep breath, and do your homework.